complete that example with local functions. Just one more small little concept and then we'll take it forward. So why have a local function? Why have a local function?
Sir, if some data from that function has to be used in some other function, so we can use that. We have to declare that function within that function to use that particular value.
Correct. So the local function can access a variable declared in the calling function, which is your outer function. Okay. Now, where can you call the local function from? I have not written it down. I did say it, but I have not written down. So can be called only from within defining function. Right. I have not written that line down, but I've defined the local function here within this function. So you can only call it from within this function. So what if I had another local function? Let's say do something else too. Okay. Can you call do something else from do something else too? Would that be possible? You think this would work? Yes, no?
No, sir.
It is working. It's like the question is, see, if you think of this like a variable, this is like a variable, right? If you think of this, assuming it's a variable, can you access this variable from within this function? Yes or no? If instead of this, if this was a variable that was defined, where is the variable defined?
Inside a function.
Inside this do something. So will do something else to be able to access a variable declared here?
Yes.
So if it can access a variable declared here, can it not access a function defined here?
Yes.
Yes, it can.
Right? Yeah. So you'll find that you can do this. You can access another from here. But supposing I had a variable in here, let's say I had an int j, for example. Do you think this can access the j out here?
No.
The j defined here, will it be accessible here? No, that won't work. That won't work. So here within this, it can access, members defined within the defining function, the outer function, but not within some other function. It can call this function, but not access a variable defined. Okay. So these are things that I expected you to try out and then, just have variations. What if I did this? What if I did that? What if I did that? So on and so forth. All right. So now, let me show you something else. Normally, we define a local function so that it can access a variable declared in the calling function, in the outer function. But if I declare this function as a static local function, so this is a static local function. The static local function cannot access a variable declared in the outer function. So you'll find that, okay, you'll find that this is not working now. Why is this not working? Because if you declared it as a static local function, it simply says that you cannot access the variable. Normally, you can access all variables, but this is what we are trying to do out here. Okay, so that's the difference between a static local function versus a regular local function. Now, why have a static local function? Because see, the reason we said we want a local function is so that it can access variables here. So why would you want to define a static local function? What, you're defeating the purpose for which you wanted local function. But what are you gaining from here? What can happen here in this code? Where can you call this code from? Where can you call this code from? Yes? Hello? Are you all here?
From the static function.
Main.
Not from main.
From do
here.
something.
From do something, from the defining function. So this do something else too can only be called from where? can only be called from where? From within this function. So you're limiting it. You're saying that now the function is limited to what? To this scope, to whatever, wherever this begins, and wherever this ends, this is where you can call it from. So although you don't get the benefit of what we wanted to do here, the other restriction is still there, which says that it can only be called from within the defining function. That's how your static local function works. Now, don't think of this like your static variable or static functions at the class level. This is a different concept altogether. This is a local function, right? And by marking it as static, you're just simply, what is the differentiator here? It cannot access a variable declared in the calling. Clear on this, everybody?
Yes.
All right. So this is the section that I could not sort of complete yesterday. I would have liked to do that also yesterday, but we ran out of time, so to say. Any questions about this before I move on? Okay. So I'll upload day one code also because I made some changes in there, but I'm going to move on to a different project altogether. So let's start with what we have planned for today. I'm going in for a new project, console app again, and calling it day2. And let's call this project as properties. Same settings as yesterday, and create. Okay. So yesterday we saw how we could create, methods in our class. Let's see how we can create data members. So if I said public int I, for example, this is a class level variable that you're creating. Before we access it further, there's one small difference between class level variables and local variables. So here, if you have a variable defined within a function, you'll find that, if you try accessing it directly, it gives you an error. So why does it give you an error here? What do you think the problem is?
It
No.
must be initialized.
Correct. So this by default is unassigned, right? And because it is unassigned, this is giving an error because you can't access it directly. You have to give it an initial value. And when you give it an initial value, then of course it can pick up the value. But otherwise, by default, the value in here is unassigned. It does not give it an initial value. So I'm purposely putting this on a separate line just to show you that you can give this. And that's where it's getting a value, and then they can access this. But if you try creating a class level variable, so let's say now I'm trying to access it through an object, class 1 was equal to new class 1. And if I try printing this value directly, okay, if I try printing this value directly by saying o.I, you'll find that it does allow you to access this value directly. And by default, an integer would be assigned a value of 0. So numeric, variables would get the default value of 0. If you had a string, for example, it would then get a default value of null. Or if you had a Boolean variable, it will get a default value of false. If there are objects that you're using, they will have a default value of null. So it does have a default value. It is not an unassigned variable. So that is the difference between a local variable, right, defined at the function level, versus a class level variable, which will get a default value. Are we clear on this, everybody?
Yes, sir.
Yes, sir.
All right. So let's quickly run this code. So you'll find that the class level variable is getting a default value of 0. The second 0 that is being printed is the class level variable that's being printed. Now, what if I'm trying to access a value in here and I'm trying to put in a value in here? Let's say if I try putting in O1 O.I is equal to whatever, 1000 for example. Okay. So initially now it was 0, of course, but when I set it to 1000, you would get the value of 1000. So the second variable is getting a value of 1000. Now, when I'm creating my class, I want to put in a sort of a validation or a constraint on here, which says that the value that I'm accepting into I should be less than 100 only. I don't want any value more than 100 to be accepted. So right now, of course, there is no restriction. It can accept any value. How do you suggest we can put in the restriction? It says that I should get a value of less than 100 only.
Maybe if statement
So where would you write the if statement?
before O.I is assigned. Sorry,
Here.
after O.I. Yeah.
Here. So here is what you'll do.
Before the console statement.
All right. Now I have a problem with that approach. The problem with that approach is that you need to understand that the person who's creating the class and the person who's creating an object of the class are not necessarily going to be the same person who's doing this. So always think that the person who's creating the class is a different person and person who's creating an object of the class is a different person. Always think in your mind. Now I can understand that you are doing both the jobs, but these jobs are going to be done by two different people. The person who's creating the class, I'm calling him the developer. And the person who's creating an object of his class, I'm calling him a user. And I'm saying that the developer and the user are two different entities. Now, if I do what you are suggesting by writing an if somewhere in here, anywhere in here, if I write an if, then the user will have to create an if statement for every object that is created of that class. Supposing there are 1000 objects created, you'll have to write 1000 if statements, all doing the same code. And that is not what we want. We want that the class should be able to put in a restriction saying that this is the valid data that I can accept in there. And then what would happen? Any object that you create would get the validation for you. So what you're saying is not syntactically wrong, but fundamentally it is very flawed. Understood?
Yes, sir.
All right. So what can we do now? Can you suggest an alternative?
Sir, in line number 21, we can set some limit there itself so that,
How?
yeah.
How?
Oh, no, I don't know actually, but yeah, that if that way, while declaring only, we are able to put up that.
No, there is no direct way. There's no direct way. If you're asking me, is there a syntax by which directly I can put in a constraint there? There's no direct way there.
Okay.
By writing constructor?
So constructor would mean it will be called here, no? Constructor would mean that that code will be called here. But
Sir,
I want that
getter and
this, I
setter.
want one second. I want one second. Let me complete. I want this line to validate it, not this line. You're telling me that when I'm creating an object, I will validate it. But after creating the object, now he can change the value. Agree or no? So constructor is not the answer to that. Yes, what is the answer that I got after that? I interrupted you in between. Writing a
Setter method.
Writing a getter and a setter. So you need to write a getter and a setter method to make this work. So what are the getter and setter that you could be writing, or how could you be doing that? Help me with the setter and the getter. Public. Let's start with the setter first. Void, let's say set I. Yeah. Help me with the code. What should the set I take? This is your setter function. Yes.
parameter as a input int I.
Parameter as something. Let me call this as value. With your permission, can I call it value?
Yes, sir.
Okay. And what would the code be now? If yeah, value less than 100, that is what I wanted, then I is equal to value, right? So when you are calling this, you are now checking that the value should be whatever validation that you want out here, and only if it is validated, then put a value of into I. But this doesn't prevent me from directly putting a value into o.i. I can still do what I'm doing right now.
Make private.
So first thing that you need to do here is make this I as private. Moment you make this as private, it would not allow you to do what? Not allow you to access I directly. So now this code doesn't work. You can't, access I directly. The only way you can access I right now is through the set function. And in the set function, we have a validation here. Now, typically you would need to write an else as well. So if it is valid, then do this. Else what? Else what would you do? If it is not valid, then what do you want to do?
Return.
So ideally, you would want to throw an exception. Right? Ideally, you would want to throw an exception. If the value is not valid, then don't let him continue. But at this point, I have not, I don't want to introduce you to exception handling code at this point, because I want to cover a few concepts before I get to exception handling. So I don't want to do that at this point, but this is ideally what we'll be doing. Yeah, somebody's mic is unmuted. Right? Pay attention to the session. Don't do things outside. Otherwise, you might as well not attend the session. Attendance here is not mandatory. But if you want to log on and have your attention somewhere else, it defeats the purpose of having to log on. Okay, no movie going on where you can walk in and out of whenever you want to. Attend the session, with all your concentration, or don't attend it. So the point I'm making here is that the throw new exception is ideally what you do if a value is not valid. But right now
we can add simply a error message writing not valid.
So right now I'm going to commit a crime. I'm going to make a big mistake right now. I'm going to do something that is unpardonable right now. Right now, I'm directly going to put in the error message saying console.writeLine invalid I. And this is horrible code. Don't ever write down code like this. Don't ever write down code like this. You should not be doing this. If you have ever done this code, then you have already committed multiple crimes for which you should be arrested. So this is horrible code. Don't do this code ever. But right now I'm being forced to write down this code because I don't want to get into exception handling at this point of time. Okay. So we will come back later. We'll come back and we will, after we have done exception handling, we'll correct this code. But for now, this is not the right way of doing it. This is just because I don't have an option, I'm doing it right now. Okay.
Sir, can you call setI method again in else?
It'll what do you want to do? I mean, of course you can call it.
So we will assign again. We will give the permission to user to assign a value again.
No. Again, correct syntax, flawed approach. Correct syntax. Syntactically, what you're saying is correct. But conceptually, you should, what I'm doing here, I'm going to be put into jail for that. I'm committing a crime. You're going to be in the cell next to me. You're going to be in the jail next to me. You're committing also the same crime. So we'll explain later. I'll explain later why is this a crime. So answer to your question is, can you jump off of the 25th floor of a building? Can you?
Yes.
Yes.
Can
Yes,
you?
sir.
Can you?
Yes,
Yes, sir.
Should you?
Yes,
Yes,
sir.
sir. No.
Should
No.
you?
No.
So answer to your question is, can you do that? Yes. Should you be doing that? No. We'll discuss this later. I'll tell you later why you're not to do this, or why is this a horrible approach, or why am I putting myself in prison for writing code like this. So right now I'm just doing this because I don't want to, confuse you with too many concepts. So let's just keep it simple right now. But remember this line on Tuesday morning at whatever 10:28 a.m. we have done something horrible, and we will come back and correct it later. Okay, come back to this. So this is what we have done in the set I. Now, which means now he can now pass the value with what? O dot set I of some value. So if he passes an invalid value, what's going to happen? If he passes an invalid value, what's going to happen? Value will receive, let's say 10,000. It won't go into the if, it will go into the else, and currently it will show you what? A error message out. What will happen if you put in a correct value? Let's say 10. Then what will happen then? In that case, what will happen?
Value will be assigned to I.
I will get the value that you're giving. Okay. Okay. Now, how do I print the value? If I try printing the value, O dot I is still not available to me. So what do I need to do again here? Just like you have a setter,
Getter method.
you have to have a getter. So public int get I. And code in here is relatively simpler. All that we're doing is what? Return the value of I. And instead of calling O dot I, now you would call O dot get I.
Get I.
Right? So if it's a valid value, then it should show you the value. Let's try running it with the valid value. So it shows you 10. Okay, the earlier one, ignore that. That is the console.writeLine for this one. I don't want that to run. But if it was an invalid value, then what's going to happen? What value will it return now if it was invalid?
Default
So what is the default value? Correct answer. What is the default?
0.
0. Right? Invalid I, and that returns a 0, because by default variables, integer variables are initialized to 0, class level variables. Are we clear on this, everybody?
Yes, sir.
All right. Now, I have a problem with setters and getters. Supposing I had a variable called j, let's say. Okay, I've purposely kept it as public. Now I can write code like this. O dot j is equal to, let's say plus O dot j plus O dot j plus minus O dot j minus O dot j minus. Okay, so let's say I'm doing something, a complex calculation here in some way. Now I can do this with j because j is a variable out here which is public. But if I had to write the same line for I, how will I do this for I? Instead of j, I want to do this for I. Can I do this for I?
We can store I. We can store I value in a separate variable.
No, that would mean an extra operation. I'm asking you, can you manipulate I directly? That would mean what? You're storing into a variable first, then doing it to the variable, then putting it back into I. So I don't want that. I want to work with I. Supposing, like, I'm just giving an example. Supposing like I, there were 20 other variables. That means 20 other variables you have to create. Assign values and return values, all of that extra code comes in for no reason at all. So how do I do it with I? Yes. Give me the code for doing it with I, with the setter and the getter. Yes, please.
Hello, sir.
Yes.
Line number 17 define in another method, and that method will be called from class 1. And when we call the method, we have to pass I value.
I want a simple calculation. we said that these are variables that you were creating. So I was initially a variable that you were creating, but because you wanted to add validations on it, you added a set and a get. Now I want to use that same variable. You're making life so complex for me. I want an easy life. I want to use that variable in my code. Can we use it in the code directly using the set I get? Directly, can we do it?
No, sir.
See, it's not impossible. It's not impossible to do. It is possible to do it, but it is very, very complex to do it. An operation which is so simple, which if you have to use a variable becomes so simple. If you, the moment you write a setter and a getter, life becomes so complicated for you. Yes or no? You agree with me? The problem with the setter and the getter is what? Ease of use is not there at all. It's very, very difficult to use.
Yes,
Agree
sir.
with this statement or no?
Yes, sir.
Yes, sir.
Yes, sir.
So in .NET, instead of a setter and a getter, there is a better way of doing it. And this better way is to create a property. Now, when you create a property here in C# code, you get the best of both worlds. So what are the best of both worlds? You can write validation code like you write in the set and the get. So you can write code this way. You can put in validations this way. But while accessing it, you can access it like a variable. I'll repeat what I'm saying. When you create a property in .NET, you get both benefits. One benefit is you can write code like you write in set and get. The second advantage is while accessing the property, you can access it like you access a variable. Are we clear on this?
Yes, sir.
All right. So let's try the same thing with creating a property. So I have just shown you this code of what not to do. This code, please look at it carefully and never again use this code. Don't ever write code like this. Don't ever write a setter and a getter. Instead, what are you going to use? You're going to use a property. Okay, so let me make a copy of this code and I'm going to be okay. All right. Now I've kept this class as a comparison. I've kept this class as a comparison. Let me write another class here. Okay. And let's see how to create a property. Now, while creating a property, the code that we're writing will be similar to what we had done earlier. So I had a private variable I. I'm going to create a private int. I'm going to create a property called P1. Okay. Now, when you create a property for P1, this is not the property. This is the variable for the property. There is a certain convention that will follow. So let me create the property and I'll show you what I mean by that. I'm saying public int P1. Now this here, I'm going to create it as a property. P1 here, this one here is the property. And a property, you will not end it with a semicolon. Instead, what you'll do is after the property name, you put in curly brackets and you'll have a set and you'll have a get. So what is the property actually? A property consists of two functions, a set and a get. Just like you had a setter and a getter, you would have the same similar structure in a property. For storing the value. What did we have with the setter and getter? Setter and getter was storing the value where? Storing the value where? Setter and getter was storing the value where?
In
Yes.
Class level variable.
In object.
In a private variable, class level private variable. So here also the property is going to store the value where? Into his private variable, which is at the class level. Right? Now when you're doing this, the convention, it is not a rule. It is just a convention, is that the property name will begin with what? Capital letter. And the variable name will begin with small letter. So if you had a property called roll number, this would be called roll number in this way. And the variable will be called what? Yes. Roll number with a small r.
Small r.
Right? Or for example, let's say if I had a property called name, then this would be called what? Small name. Okay. So I'm creating a property called P1, capital P1. So what will this be called now? Small p1. Okay. Supposing I had a property called I. Variable will be called small I. So that's the convention that you would be using. So that's what I've used out here. Okay. Now what I have here is a set and a get. Now the code for set and get is going to be very similar to what we've done out here. So look at the code now. Look at the code that I've written in the set I, get I, and I'm going to write similar code out here. I start off with saying if value less than 100, P1 equal to value. Else, committing the crime now, console.writeLine, invalid P1. Are we clear on this? So look at the code for set out here, set out here, and set out here. And what do you notice out here? First thing is, what are the basic difference here? This set I required what? Set I had what?
An argument.
It had a parameter, but this set does not have a parameter. Now, what about if he enters a value? How do you get the value then? So you here have a keyword called value. You notice it's shown in blue. Everything in blue is a keyword. So here in this case, if value less than 100, this word value, this is a keyword which indicates what is the value that is being passed down to you. As opposed to here, what did we have to do? We had to actually create a variable. The code, of course, is the same. The code that I've written here is exactly the same. There's no change in the code. Are we clear on this, everybody? Yes?
Yes, sir.
Yes, sir.
Yeah, what's your doubt? Somebody was asking about it.
Yes, at line number 70 and 71, the variable name is same P1. I'm not getting it.
It is not the same. Small letters, capital letters.
Okay.
Okay.
Okay, sir.
See, this is not a variable. Line 71, what are we creating? What is this now? This is your property. In a property, you're not ending it with a semicolon here. What are you doing instead? You have curly brackets under the property. So the property is getting over here at this point. And this here is your variable. So both of them are not the same. So don't say it's a variable. This one here is a property. Property consists of two functions, a set and a get.
Okay, sir. Got it. Thank you.
Okay, look at the get. Look at the get on top and tell me what code would I write in here in the get. It's actually showing you, but anyway. Tell me what would I do here instead? Yes?
Return P1?
Correct. Return P1. It actually even showed you the code before I even asked you. So this is what it actually is doing out here. Okay. Now let's see how we can run this code, or how is this being called. So when I create an object of that class, class 1 O is equal to new class 1. And if I did O dot P1 equal to some value. So when you do this internally, it will call the set. So what is P1 now here? If you, I don't know if you noticed, but when you did O dot, here has been shown here as a property. Look at this. This is symbol for a property. So O dot P1 is equal to 10. And similarly, to read the value, I would now access it as O dot P1. And this is now calling the get. So if you notice, the syntax that you're using is very similar to what are you doing? Syntax that you're using is like what?
The way we are initializing class variables.
Correct. So syntax is like a variable. But when you use the O dot P1 equal to 10, what is it internally going and calling? Internally going and calling what?
Set
Not the
method
set
of
and get.
property.
I'm saying when you say equal to 10, one specific answer, it is calling the set. Don't say set and get. When I'm saying equal to 10, it's calling the set.
Set.
And when I'm trying to read the value, at that time it's going and calling the get.
Get.
Okay. Now, whatever value I'm setting here, I say O dot P1 equal to 10, whatever value I'm setting, this value that I've given on the right hand side is coming down as what? Is coming down as value. Are we clear on this? There's no parameter. It's coming down as value, which is the keyword. This value is only available in the set. It will not be available to you in the get. It's only available in the set. What is the data type of value? Right now, it's showing it as an int. It's showing it as an int because your property is an int. Instead of an int, what if, for example, this property was a decimal? Value now becomes decimal. If instead of decimal, if it was a string, value would now be a string. If I take it as bool, value is now a bool. So this value would depend upon how your property is created. So this is what I originally had. Since the property was an int, the value here also is an int. Are we clear on this?
Yes, sir.
Sir.
All right. Let me run this code and show you first. Yeah. Is there a question? Was somebody asking something?
So the value that you have used in the set method, this value, how is it recognizing that it is for P1? Means how to
Because when you call O dot P1 equal to 10, it is going to call the set for P1. This line is going to trigger off this code. And whatever you passed on the right hand side is going to be passed here as value.
Okay. Okay.
So this set, where have we written it? Where have we written the set? Inside P1. No?
Yeah.
Understood?
Yes. Sir.
All right. So let me run the code once and show you. If I run it once and show you, then it shows you that the value entered was 10. And if I had given an invalid value as before, what will happen? What will happen now? Invalid value will cause what?
Invalid
You'll go to the else, show you invalid P1. And what is the default value that will be returned here?
0.
0.
0. So same as before. Working is the same as before. No change in what happened earlier to now. But why is this much better than writing a setter and a getter? Why is this code much 1,000 times better than writing a setter and a getter?
You don't need to rewrite
directly
this
call
set and get.
Because it is giving a fixed value to the class variable.
No,
It
because you
is
can
it
use
used.
it like a variable. You can use it, the syntax that you're using, it is like using a variable.
Okay.
And I gave you a question some minutes back. If you have to write code like this using a setter and a getter, you all were not able to do that. Yes or no? because you know how to work with a variable, but you don't know how to call those functions as nested functions. Very, very complex code. All 250 of you all could not answer that question. Yeah, how do you do this with the setter and the getter? Now, can you do this with the property? Can we do this line of code with a property? Yes or no?
Yes,
Yes.
yes.
Of course you can, because you're using it like a variable. The moment you use it like a variable, in your mind, it becomes so much simpler to use. So that's the benefit that you're getting. Your syntax is like a variable, but behind the scenes, it is also calling a set and a get. So it's the best of both worlds. Okay, advantages of everything. Advantage of using it like a variable with additional advantage of writing validation code like you write in the set and the get. All right. Any questions, any doubts before I take it further? Okay. Now I'm going to show you how this is working by adding a breakpoint. Now to add a breakpoint, look carefully. This is a UI feature. Just go to the left out here, in line number 49, go to the left and click on that. So it adds a breakpoint and it's a toggle. So if you click on it again, it removes the breakpoint. So that's how you can add a breakpoint. So I'm adding a breakpoint like this. I'm adding a breakpoint in my set as well and in my get as well. Okay. Now when I press F5, it comes and waits at the breakpoint. And what you can do is you could go into debug and step into. So this will take you one line at a time. What's the shortcut key for that? Shortcut key is
F11.
F11, right? So you can do it from here. You can every time go and click on this and do this, or simply press the F11 key. So I'm pressing the F11 key. If I'm going to the next line, see what happens next. From line number 49, where is it going to jump to?
Number 76.
From 75, 76, whatever. Okay. So from here, it's going to go into the set. Now in the set, it's checking out for what? Value less than 100. What are the value and value that I'm going to get? Value is going to get what value right now? What will be the value in value? 10.
10.
So now how do you see this? You move your mouse pointer onto value and it shows you that the value is currently 10. And then of course the code runs. So if it's less than 100, then P1 equal to value. I'm doing F11 now, one line. All right, comes back here and finishes this. Next, what is happening? Console.writeLine O.P1. So you're trying to read the value. When you try to read the value, what is it going to call now?
Get method.
Get method. So let's look at get. So you go into the get now and you're returning whatever the last stored value in P1. So we had last stored 10 in it. And that's how I'm getting the value of 10. Right? And this is the output that you got, 10. What would have happened if I had given an invalid value? Let's try giving in an invalid value. So what happens now again? Again, what? F11 to run it, one line. Value in this case is what? Now 10,000. And it doesn't go into the if, it goes into the else and continues with the code. Console.writeLine again is calling the get and returning the value in P. So this is why it's giving you a value of 0. Are we clear on this, everybody? And how properties work?
Yes, sir.
Right. Questions, if any, or otherwise I'm moving on. Removing the
Hello.
breakpoints in this. Yeah.
Sir, means breakpoints is actually considering those lines of code only, right?
Yeah, I mean, it'll run up to that point directly without going step by, and then you have an option of either pressing F5 or F11. F5 would mean what? Run ahead continuously until the next breakpoint, or F11 meaning what? One line at a time. So that's up to you now how you run your.
Okay, sir. Can you show us how to use those linear operators over here using this method? that you mentioned earlier?
Which ones?
Those increment operators that you mentioned, no? That we can use it easily using this set and get method. Now as
I can use it. I can use it. But then what will you do? I can do it.
I think we'll
When
do syntactic error, something like that. That's why
it won't give you a syntax error. So I'm not going to show it to you.
Okay.
You have to also do something in the lab, no?
Yes, yes. Sir. Okay.
Or you want me to do everything for you?
No, no.
Right. So try it out in the lab. See what happens. I'm telling you that you can use it like a variable. Now, whatever way you want to use it like a variable, you use. No? Why do you want me to show it to you? Try it out. Make a note to yourself. Okay, I have to try this in the lab. Who's asking me this question?
Abhishek, sir.
Yeah, Abhi. So there are a lot of questions you're asking that I'm going to ask you back again tomorrow. Or in the next session, not even tomorrow. In the next session, we have a session, one more session today. So before the session starts, Abhi, you're going to tell me, sir, this was the output. This is how I tried it, and this is how it worked.
Yes, sir.
Okay. All right, good. Anyway, coming back to this, I'm going to take it forward. Instead of creating an int property, I want to create a string property. So look at the earlier syntax and give me the code. Let's say the property name is called P2. Tell me what all would I need to do. Give me call out code as I'm typing it out. Go ahead.
Like public string P2.
Not public string P2. Starting off with what?
Private.
Private.
Firstly, the private variable, which will hold the value for the property. So yes, private string P2. Small or capital?
Small.
Small P2. And what else now? Carry on.
Now
Public. Actually, it's prompting you. This Visual Studio is very bad. It doesn't help me in my training. It keeps telling you the answer before I even ask you the question. Go ahead. Yes.
Public.
String P2.
String P2.
Capital P2 this time. What will this have now? No semicolon there. Curly brackets indicating that this is a property. In that, what will you need to have?
Set.
A set and a
Get.
get. So set, right? And it's already showing you the code. I don't want you to see that code. And the get. Again, it's showing the code. Very, very bad. I don't like this at all. Because you all are not getting a chance to think and tell me. Achha, what would I do in here? In the set? Yes. It keeps prompting you. What should I do in the set? Typically, write your validation. So whatever validation, if whatever value, okay, and whatever validation you want to write, right? I'm not writing that validation. So you keep a check for whatever code that you want to check, whatever you'd like to check for. And if it is valid, what should I do? If it is valid, then what should I do?
Assign that to P2.
So now there are two P2s, no? So you tell me what. Which
to the variable P2.
So then say small P2 or variable P2. So, and rather than saying assign that to P2, speak code. Speak
P2
code.
equals to value.
Okay. So small P2 equal to value. Do not give me English, give me code. Okay. P2 equal to value. In the else part, if there was an else part, then you could write down the console.writeLine, which we said right now is a crime, but otherwise you could do that. In the get, what would you do?
Return P2.
Return small P2.
Right. Return the variable P2. Return the small variable P2. So you notice that the get is a lot simpler. There's no validation in the get. You're just returning that variable. So the get code would be more or less standardized. And what would keep changing is the condition that you write out here. That would keep changing. Value now, what will be the data type for value in this one?
String.
Value would now would take it as a string. So if you see, this has become a string. Are we clear on this?
Yes, sir.
Yes, sir.
Okay, how do I call it? How do I call it? O dot P2 equal to some value. And there's no validation right now, of course, so it's not going to do anything. O dot P2 being printed. So that's your set being called, and that's your get being called. Okay. Any questions, any doubts with this? Okay. I'm creating another property P3. Okay, I'm just making a copy of this. Let's call this P3. Okay. Can you tell me how to create a read-only property? Can you tell me how to create a read-only property? What do I mean by read-only?
The
No
value cannot
changes.
be changed.
So cannot change a value, but can only return the value.
Like
So what
final
should
value.
Final keyword.
you are simple. You don't give me Java.
Sir,
Here, how do I? Did you have a property in Java? Have you learned about a property in Java?
No, sir.
So
No,
I'm
sir.
asking you, how do you give me a read-only property?
Sir, instead of value, we can write some.
Simple.
Without set.
So
we can initialize P3.
Okay, I'll initialize it, but how do I ensure that only it can be, you can only read
Property
the value,
without
you
set.
cannot change the value.
Without set.
So remove the set. If you don't have a set, it means what will happen now? The user can't change the value, but he can return a value. Now, right now, by default, it will give you a null because by default, everything is null. So if you want, you can give it an initial value. Somebody suggested that you give it an initial value. So what have we created out here? We created a read-only property. Now, what will work and what will not work? If you try to assign a value, will that work? O.P3 equal to some value, will that work?
No, sir.
So it's giving an error saying that property or indexer P3 cannot be assigned to since it is read-only. But what would work?
Console.writeLine.
If you try to read the value, that would work. So this is an error, but this would work. Clear? All right. How do you create a write-only property?
Without get.
Correct. So have only the set, but don't have the get. So read-only properties are created more often in your code. Write-only properties are not really very much in use. Read-only properties will happen a lot of times in your code. I can't think of good examples for write-only properties, for you to use where you can change the value, but you can't read the value. So I don't think there are a lot of places where you would need to create write-only, but if you had to create it, you know how to create it. Are we clear on this? All right. Now, I'll go back to my fundamental question. I keep asking all this question. Why have a property? Why have a property? Yes?
Because
For
we can
validations?
access it direct.
Correct. One word answer was very good.
For validation.
Correct. So if you want to have validations in your data members, then instead of having directly variables at the class level, you can create them as properties. Perfect answer. Why have properties? For validations. Okay. Now consider this property here. Consider this property here. Okay. I have not written any validations here. Okay. I told you all that if you all want to, you can write validations, but right now, of course, this property does not have any validations. So instead of creating it a property like this, can I alternatively also have done something like this? Can I also have done something like this? What am I doing on line 115?
So you are just declaring a property, but
It's not a property. It's not a property.
It's a variable.
variable, sir.
Variable.
It's a
Okay, so
variable.
variable now. Yeah.
Just because you've done a property, you don't forget your earlier concept. No?
Yeah, yes, sir. Yes, sir.
So what is this? This is directly a variable. So now tell me whether this code here, starting from line number 93, starting from line number 93 up to here, up to line number 105, is this similar to line number 115? Aren't they both doing the same thing?
Yes, sir.
Sir.
Right? Why have a property? Why have a property?
For validation.
For validation. So if there is no validation in there, instead of a property, can we keep a public variable directly?
Yes.
Yes, no?
Yes, sir.
Yes. Understood? So if you
Yes,
don't
sir.
have validations, I'm saying the alternate way is what? To create a public variable. By the way, if you create a public variable in the form or in the class, if you have any class level variable, this is also called as a field. What is a field? Another word for a class level variable. So in .NET, we also refer to it as a field. Okay. It means the same, class level variable or field, meaning exactly the same. So my question to you is, given the choice between line numbers 93 to 105 versus line number 115, which would you choose and why? Which would you prefer and why?
Sir, 115.
Depends on the situation.
Why? Why? No, you said one. Let her finish. Why?
Sir, because we have to write less code and it will be much more maintainable.
Yeah, easier, much easier, lesser code. How many lines that one? 93 to 105. 12 lines. Even if you remove the comment, it's still 12 lines of code. Instead of that, you just write one line of code and it should work. Right? So logical answer is what? That using a field is much better. If what? If
we don't have to validate.
Right. If you don't have validation, if you have validation, then don't thinking about it. Then properties are better.
Yes, sir.
Now, even though fields appear better, .NET suggests or Microsoft suggests that even in this situation, you should create a property. So they're telling you, yes, we know that logically speaking, a field should be better. But they're saying that even then, please create a property. So why are they asking us to create a property instead of a field? Couple of reasons. First reason is they're saying in case in future you decide to write validations. See, today you're not having any validations. But let's say in future you have to write validations. If you have a field, it becomes very difficult to write validations for that field. But instead of your property, all that you need to do is what? You just go and put in the code in the set. Just put in the validation code in the set and you're set. Yes or no?
Yes, sir.
So they're saying, yes, we know what you're saying. They're saying, yes, we know that right now you feel fields are better. But we are suggesting that even then, one reason is because in future, you may decide to add validations. Or what if you want to create, let's say, read-only properties or write-only properties, right? Then doing it with the field is not going to be possible, but doing it with the property will be very easy to do. So that's one reason. The second reason they're saying is because of standardization. Now, when you create an object of the class O dot, look at P1, P2, P3, P4. Look at P1, P2, P3, P4. What has happened now? Can you see the symbols out there? P4 is what?
Field.
Is a field. And the other three are properties. So your class will end up having some properties and some fields. So it becomes very, it doesn't have the same standardization. Instead, what are they saying? Create all properties only. That is what they're suggesting. It's a suggestion. It doesn't mean that you have to do it. It's a suggestion. They're saying from a convention point of view, rather than having fields, please have properties. Are we clear on what they're saying? What are they asking you to do? Yes or no?
Yes, sir.
But you as a programmer will say, what is this nonsense? 12 lines of code you are asking me to write? 12 lines of code you are asking me to write. Instead of that, I can write in 1 line of code. Yes, so that will be your argument. What is this nonsense? Oh, standardization and all that, tel lagani. What is this? I want to write only 1 line of code. Why I have to write 12 lines of code? That will be your response. Agree or no? So Microsoft said, okay, if that is the case, I'll give you an alternate syntax of writing a property called as an automatic property. Okay. And in the automatic property, I will greatly reduce the amount of code that you need to write. So look at this automatic property that I'm creating. Public string p5, and which has a get and a set. So if you look at this now, syntactically, it is similar to, it is not the same as, but it is similar to what? Similar to creating a field. Similar to, it's not the same. It's by no means the same. It is still longer than the field, but it is much shorter than doing what? Much shorter than doing what? Creating your own property out here. Agree or no? Much shorter than doing that. Okay. So they're saying you can create an automatic property here in this manner. Now, when would you create an automatic property? First condition, of course, is that there are no validations. If there are validations, then you cannot create an automatic property. So first condition is what? No validations.
No validations.
Right? Second thing is, when you create an automatic property, the compiler generates the code for get and set. Okay. Not just that. Besides generating the code for get and set, it also generates a variable. Right? Also generates a variable. What variable are we talking about here?
P5.
P5.
The variable that was going to be used by P5. So we have not written a variable anywhere. You see this everywhere else. What have we been doing? For P3, we created a variable. For P2, we created a variable. For P1, we created a variable. But for this one, I have not created any variable. So who's generating this variable for me? The compiler is. And it's also generating the code for the get and the set. And that's how you can use a automatic property. Are we clear on this? When would you create an automatic property? When would you create an automatic property?
No validations are needed.
You don't have any validations. So rather than creating a field, they're suggesting please create a automatic property. Understood?
Yes, sir.
Yes.
Sir, in line 116, does it also create the variable?
Line 116 is not a property, no? Line 116, is this a property?
No, sir. It's field.
What is it? It is a class level variable. Okay, so don't forget your earlier concepts. You knew how to create a class level variable. Nothing has changed since then. Just because I've created a property does not mean that you change the way in which you create a variable. Understood? All right. Yeah, any other queries? Okay, so let's go and try writing code for this. How do I call the code? Like I would do normally, o5.o.p5 rather is equal to some value. It's a string, right? And similarly, console.writeLine o.p5. So I'll continue using it the same way. If you run this, then it gives you the output as you expect. The last line, of course, would be showing the P5 value. Okay. All right. Now it means I've said so far that the compiler generates the code for get and set, and it also generates a variable. So let me show you what is happening out here behind the scenes. Okay. So what I want to do next is I want to open the assembly and show you the IL that is getting generated for that. And in the IL, I'll show you how the compiler is generating the code for get and set, how it's generating a variable, and so on and so forth. Okay. Now to do that, I'm going to ask you to note this down and do it later on your own. Open the developer command prompt for Visual Studio 2022. Right. So it opens a command where you can give commands out here. Command window it opens, but with settings for Visual Studio. Okay. I have that in my list of shortcuts here. That's my developer command prompt for Visual Studio 2022, where at the command line, give the command ILDASM. So this ILDASM is a utility, again, a command line utility for IL disassembler. It's called as the IL disassembler. So the IL disassembler allows you to open the assembly and to see the contents of that assembly. How is the assembly looking out here? Okay. So run this the command line. This opens a window for you for the ILDSM. And we're going to go and open that assembly and see that. So I'm going to go to File, Open. Okay. And JK Jan 23 is where I've saved it. Day 2. Name of my project was Properties. Under Properties, look in the bin folder. Under bin, debug. Under debug, .NET 6.0. And you'll find that there are two files showed to you, properties.dll and properties.exe. Why is the exe file being generated?
Runtime for runtime execution.
Because we have given a main function. Because this has an entry point. Now what happens behind the scenes is that in .NET Core, so it works a little differently in .NET Core and .NET Framework. Okay. In .NET Framework, it only creates one file which you can run directly. In .NET Framework, I'll repeat, it only creates one exe file which you can run directly. But in .NET Framework, it puts the code into a .dll file, but generates an exe file to launch that code from the DLL file. So when you have an entry point, when you have a main function in .NET Core, it's generating two files for you. A exe, which contains the entry point, and that code launches the code from the DLL, which contains all the other code in there. Okay, slight difference out here. So it's like a wrapper to run your code.
So, sir, exe file won't be having the remaining portion? Only
No, it doesn't have anything. It only has code to run the code from there. It's like a, environment for running your code. Okay. And all the code is actually in the DLL file. So I'm going to open the DLL file to show you the code that is generated. Exe file, if I try to open it, gives you an error saying that I cannot open this. Okay. If I try to open the DLL file, then it shows you what is there in the DLL file. So let me show you what we have got in the DLL file and what we had written down and how it was there. So compare it on the left hand side. This is the code that I had. So you have two namespaces, property 1 and properties 2. right? Before I do that, what does it also have in the top? What is this?
Assembly
The
manifest.
manifest, correct. The assembly manifest. So if you open the manifest, this is an IL format, so you may not be able to understand this, but you can at least see this in the sense that you can at least see what's happening in here, right? And a lot of it may not be, understood by you, but don't worry about this. You get a gist of what is it. This is basically details about the assembly. Okay. All right. Now you also have two other namespaces that it creates, one for code analysis and one for compiler services, which is not code that you have written, but which is it's requiring for running the code. So ignore those, this thing, focus on the ones that we have in here. So let's look at properties one. What did it have out here? Properties one, what did it have here? Internal class program and public class, class one. So under that, there are two classes here, class one and program. Similarly, properties two also had, I had three classes actually here. So if you look at properties two, it's at these three classes. Let's look at class program. What did class program have in it? Class program had what? Had a main function in it. And let's come back to program and see what all it has generated. So one is the main function. This is the code for main. What is the other thing that you see out here? CTOR. Any guesses what that could be? CTOR.
Constructor.
Correct. Now we have not written a constructor. We didn't create a constructor, but it has created a constructor for us. So what constructor is this now?
Default.
Non-parameterized default.
Default constructor. Correct. So in a class, when you don't write a constructor, what does it create for you by default? It creates a
default
constructor.
Default constructor which doesn't take any parameters. If you see this signature here, what is it? Void. So it's not taking any parameters in there. Are we clear on this?
Yes, sir.
Okay, now we're going to do constructors in the next example, so that will help us understand how this is working. So this is what we've done here. The second thing that I wanted to actually see was not this class, but class one. I wanted to show you this, automatic property and how it generates the code and all that. That's what I wanted to show you. So let's go back to class one. Let's start with first private int P1, line 82. You see what it has done for you here? Private int P1 has become what?
Private
int
32.
32.
Int P1 has been converted to int 32.
32.
So what is this int 32?
Common type.
Correct. This is the CTS common type system type data type that it has. So when you write code out here, it is internally converting your int to the CTS types, right? So now here, let's look at the property. Line number 83, that's your property, which has a set and a get. So look at this, P1, this is the get for P1. And similarly, there is a set for P1. Okay. Now the code inside that you may not understand. That's IL code, so don't worry about that. But if you read it, you'll get the gist of what is happening. You may not understand exactly what's happening. You get the gist of that. Now it has done that for the other properties also. So P2 also, what has it done? Yeah, get and set for P2 also. P3 was my read-only property. So it only generated the get but no set. And finally, P5. So if you look at P5, what all has it done? First thing, it has generated the code for the get. Right? Secondly, it has generated the code for the set. And besides that, it has also created a private variable. So where is that private variable created? Can you point it out to
So
me?
P5, backing
This
field.
one. Correct. So P5 and angle brackets K underscore backing field. So variable name that generates will not have the same name like, small P5 and all of that. It'll have some weird looking name. And you cannot access this variable in your code. The private variable that it generates cannot be accessed in your code. You can't do that. That is internally being used. So where is this variable being used? This is being used in the get. You look at the get. It is actually returning this. Or in the set. Right? So it is actually storing the value in here. So this is what is actually being used. So this is what I meant by, for an automatic property, your compiler is generating the code. Are we clear on this, sir?
Yes, sir.
Yes, sir.
All right. So this is how you can sort of see this ILDSM. Now, I am not going to tell you every time that look at ILDSM. But quite often while explaining things, I will tell you that behind the scenes, this is what is happening. Behind the scenes, this is what it does. How do you now go and check that out again? You can open ILDSM and see what's happening in there. I won't tell you that, okay, open ILDSM. But every time there's a new concept coming up, and if you want to see that what is happening in the background, the ILDSM is a good way of doing that. Okay, so feel free to come back to ILDSM at any point of time, open it, see what the assembly looks like. It will help you understand what is happening behind the scenes. Right, let me exit and come back. Exit from this window as well. All right, so this is how you could create properties. Okay, in the break right now, you'll have a break between now and the next session. I'm going to give you a small assignment based on properties. Okay, so I want to cover one more section and then I will share the assignment with you. But let me go on for the next concept. So the next concept, I'm doing it in a different project. So in the same solution, this is what I'm doing. Right click, add a new project. The project is of a console app type only. I'm not changing that. And I'm calling this as constructors and object initializers. Okay, next. And the default options, create a project. All right, so what is a constructor? I've asked you these questions yesterday. So what's a constructor?
It is a method without a return type.
A method generally that has the same name as the class, and yeah, you don't have a return type for it. Why have a constructor?
Initializing objects.
Correct. So whenever an object of the class is created, if you wanted to give it initial values, right, that's what you could do with a constructor. We saw this sometime back in ILDSM that even if you don't create a constructor, the constructor is created for you by default. Right? One constructor is created by default. So let's assume I had some properties here, public int p1, for example, right? When I do this, class 1 O is equal to new class 1. This is actually calling the default constructor. It's actually calling the default constructor, the one that you have, was created for you by default. Now the default constructor will be created for you if and only if you don't write any constructor. If you write even one constructor, then the default constructor will not be created for you. So the compiler says that if you are writing your own constructors, I will not create any. But if you are not writing any constructors, then I will create a default constructor for you. Okay. Currently, if I print the values O.P1, P2, and P3, what values would I get out here for this?
Default values.
So what is the default value for an integer?
0.
0.
0. All right. Okay. Now when I run this, it's going to run my earlier project first. So if I'd like to run this project first, can you make out from the Solution Explorer which project is going to run first? Visually, can you see which one is going to run first? Visually, can you make out?
Properties one maybe.
Why?
It is bold.
Correct.
Yeah.
So whichever project is shown in bold is the one that's running first. Now to change it, you can either do it through here, you can either do right click and set a startup project. You can make this a startup, or you can do it from here also, right? And this is the easier way of doing it. You don't need to click twice. So whatever project you want to run first, you can change the startup project either from here or from here. Okay. So if I run this project right now, it gives you the values as 0, 0, and 0. Okay. Let's write a constructor. To create a constructor, create a constructor having the same name as the class without any return type. Needs to be a public constructor so that it can be called from outside the class. And let's set some values for this. So P1 is equal to whatever, let's say 10, 20, and 30. Right? So if I now print these values, by default, the values would now not be 0, 0, 0, but instead would be what? 10, 20, and 30. All right. Now, what if I want these values, instead of hard coding into 10, 20, and 30, I want it to be passed to me by the user. In such a case, of course, you could create a constructor that takes parameters. So int a, comma, int b, comma, int c. And code in here would be what? P1 is equal to a, P2 is equal to b, and P3 is equal to c. And while creating an object now, instead of creating an object in this way, what you could do is you could pass it whatever values that you want. So let's say 1, 2, 3. And the values that will be printed here would be, instead of 10, 20, 30, would now be taking it up as what? As A, B, and C. So this is what I got out. Okay, but I have a problem with this type of code. So when I'm creating an object of this class, see what it's showing me out here? Showing me A, B, and C. Now, whoever is creating an object of your class, how would he know that the value of A goes to P1? And that the value of B goes to P2 and the value of C goes to P3? Is there any correlation out here? Yes. Can he make out here what is the, which value goes where? Can you figure it out by looking at this object? Yes, no?
Sequentially.
But how do you know that first one will go to P1? Supposing your properties are called, I'm just saying, let's say you're storing marks for maths, science, and physics, or maths, chemistry, and physics. So how do you know that A is going to maths, or A is going to physics, or A is going to chemistry?
So depending on position.
Positional parameters.
But how do you know? How do you know whether the variable A? Let's say I'm storing 3 marks for 3 subjects. Marks for 3 subjects are maths, physics, and chemistry. How do you know A goes to maths?
It works as positional parameters.
Darling, but how do you know which position goes into which property? There are 3 properties. Now you can call it as MCP or you can call it as PCM. So how do you know whether A is going to M or A is going to P? Do you know that?
Name parameters.
But name parameters will say A:1.
So it is not predictable, I guess.
So you don't know, na? That point I'm
Yeah.
making here is, how do you know that A, you're not going to give maths, physics, and chemistry. You're going to give here what? A, B, and C. Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
So the problem is that you don't know what goes where. So instead of calling it ABC, what should you be calling it here in the class? Instead of ABC, what should you be calling it?
With logical names like math, chem.
No, not logical names, the property names.
P1.
Yes.
Yeah.
Yes.
Property names. Here, of course, I'm not calling maths, physics, chemistry. I'm calling P1, P2, P3. So if I say P1, P2, P3, now what is the advantage now? What is the advantage now here? When he's trying to create an object, what can he see now? What is
Order
it?
First
in
value
which
is
the
going to
variable they
P1.
assign.
Yeah. So he's not seeing ABC. Now he knows P1, P2, P3. Now he knows what maths go where. Are we clear on this? So you should not be using any variable names. You should be using what out here? Property names. Don't use any random variable names. Use property names out here. But now it creates another problem. If I try writing code like this, P1 equal to P1, P2 equal to P2, and P3 equal to P3, it creates another problem. What is the problem here?
Local
When I say
variables.
P1, it's always referring to there's no ambiguity. It's always referring to the local variable, to the function variable. It's always referring to this. There's no ambiguity. It is very sure what it's doing. What is it doing? Saying this variable equal to this variable. So to avoid this, and if you want to say that I want to refer to the class level variable, you need to refer to it as this dot P1. So what is this? This is a reference to the current object. And P1, P2, P3 are properties of a current object. And this now refers to the class level data rather than the local variables. So you know this, but I'm not sure you know the reason why you're doing this way. My problem with all of y'all is that you all know the code, but you all don't know why you're coding it that way. So it's a dangerous thing to do. You know what to do. We don't know why you're doing that. The first question you should always ask yourself is, why am I doing that? How to do that is a secondary question. So I'm sure you would have given me this code. But why, why not to call it ABC? Why to call it P1, P2, P3? These are things that is what I'm trying to tell you all about. I'm not getting the correct answers. If I get good responses from you all, then I know that you all are getting the thing correct. Anyway, coming back to this. So this is the code that we have written. So now I can create an object in two ways, either creating no parameters, passing no parameters, or passing 3 parameters. What if I want complete flexibility, that I should be able to pass either 3 parameters or 2 parameters or 1 parameter or 0 parameters? What can I do then? What can I do then? I want to have a constructor which takes 1 parameter. I want to have a constructor which takes 2 parameters. And I want to have a constructor which takes 3 parameters. And a constructor which takes 0 parameters. So what could I do now?
We have to override the constructor.
We have to set
Override, nahi darling, overload.
Sorry, overload. Sorry, sir.
So you could overload the constructor. One possibility is you could do this.
We can set the default value and use a naming parameter.
Yeah, yes. That's what I'm looking for. So I could do this. I could say this. Okay. Or I could also do what? Keep 1 parameter here, and the other 2 are getting what values? 10 and 20, 20 and 30, for example. So this is one way of doing it. But this is a horrible way of doing it. Why am I saying this is a horrible way of doing it? Supposing you have 20 parameters, how many constructors will you need to write? If you have 20 parameters, how many constructors will you need to write? 21. Why 21? One with no parameters and then up to 20 parameters. So don't write code this way. What is the better way of writing code? What is the better way of writing code? Somebody gave a solution also. What would be the better way? Yes. Yes,
Default
please.
values.
Create one constructor only. Create one constructor only and make sure that you have default value. So if a value is passed, then it will take that value. If the value is not passed, it will take the default value. So now this code replicates all the code that we have done before. And this is what we did yesterday. That instead of having multiple constructors, a better option is to do what? Write a single constructor which takes all values with default values. And somebody given a better option also. Now while calling it, you can pass it either 3, 2, 1 or 0 parameters. And if you're using named parameters, you can have other combinations also. Only third, only second, only first, second and third, first and third. All possibilities are taken care of here. So same thing that we talked about yesterday. Don't overload things if you can use default parameters. Agree? Yes?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So anyway, this is how you create constructors. Remember, whenever you're writing constructors, please don't overload constructors. Why are you troubling yourself? Why are you torturing yourself? Why are you writing so many different methods? Okay. Preferably do what? Preferably do what? Create one constructor which has default values. All right. Now, consider this example. What if I don't have a constructor which takes parameters? What if I don't have a constructor or I don't have any constructors? Let me put it this way. Now I want to also give an initial values. Right now, what's going to happen? What values are going to come out here as? All of them would be
0 default value.
0 default values. So I want to now also given some values here before I can access them. So what will I be forced to do? After creating the object, what am I forced to do now?
O.P1
Assign the value.
Correct. So O.P1 is equal to 10. What else? O.P2
P2
equal to 20 and O.P3 is equal to 30. So I'll have to do this code and assign values here individually. When are we doing this? When are we forced to do this?
when there is no constructor.
Correct. So sometimes you might be using classes which don't have constructor. If you're creating a classes, that's a different issue. But you might be using classes that somebody else has created and they have not given a constructor in there. And you could then be doing this in this case. Now, what if you had 50 properties? How many lines of code would you end up writing?
50 lines.
51, including this line. Including this line, 51, right? So creation of the object would happen on one line and then 50 lines of properties. So your code would start looking very long code. Yes?
Yes.
So let us try to shorten this code. Now to shorten this code, we're going to use an object initializer. Okay? We're going to use an object initializer. And the object initializer would look something like this. Class 1 O1 is equal to new class 1. So up to here is all the same. Look at the earlier line. Look at line 63. 62. Same things out here. But along with this, I'm also giving in different values. So I'm putting in values like this. P1 is equal to 10, comma. P2 is equal to 20, comma. P3 is equal to 30. Are we clear on this? So this is an example. What you see in here, this curly brackets. What is this an example of? An object initializer.
Initializer.
So this line of code, line number 68, is doing the same things that line number 62 to 65 is doing. These same 4 lines, I have written it in one line. So what is this part doing first? First, let's break it down. What is this part doing?
Object creation.
Creation of an object. So what is getting called on this line? Only on this part. What is getting
Default
called?
constructor.
Yeah. So it doesn't have any constructor. Doesn't have any constructor. But yes, the default constructor which is being generated, that's what is getting called. Then what is happening on this line?
Assigning value to P1.
So what is getting called? What is getting called?
Constructor initializer.
The set for P1.
Oh.
The set for P1 is getting called. When you say obj.p1 equal to 10, what are you calling? You're calling the set for P1. What will happen here? P2 equal to 20. What will get called?
Set for P2.
Set for P2.
Set for P2. And what is getting called here?
Set for P3.
Set for P3. So this line that you've written is running exactly the same way as these lines are running. From a running point of view, these 4 lines that you wrote and this line that you wrote is exactly the same. There's no difference in the running. But what are we doing now here? We are writing shorter code. Instead of writing 4 lines of code, I have done it in a single line. Are we clear on this? So,
Yes, sir.
object initializer is not optimizing your code in any way. It is just allowing you to write shorter code. It's just helping the programmer to make your code more compact. But the running part of the code is going to remain exactly the same. Are we clear on this?
Yes, sir.
Yes, sir.
Now I can shorten it even further in this way. So look at the difference between lines 68 and 69. Because I'm not passing any parameters, I can omit the parentheses and directly give in this. Okay. So line 68 and 69 is identical. Same code, exactly the same code. There's no difference. It's just said what am I omitted out here?
The default constructor is not getting called.
No. Darling, no. The default constructor is getting called. I'm just saying that there's shorter way of writing code. Please don't change your fundas. How can you create an object without calling the constructor? That will never happen, no? While creating an object, constructor will always be called.
Okay. So it's just a syntax difference.
Please don't shake your fundas, existing fundas which are there. Please do not shake them. When you learn something new, you have to add on to that, not go 2 steps back. So yeah, I'm not saying the default constructor not being called. I'm just saying this is shorter syntax. If you're not having parentheses, don't give them. If you're not having any parameters there, don't give anything. So this is just shorter syntax. It is exactly the same thing as line number 68, which is exactly the same thing as line number 62 to 65.
Okay.
Are we clear on this?
Yes, yes.
Don't cause me mini heart attacks. Don't cause me major ones also. But this is what we're doing. Understood this, everybody? Questions?
Yes, sir.
Okay. Now look at this line. This is what we had written earlier. For this line to work, what needs to be there? For this line number 71 to work, what needs to be there?
Parameterized constructor.
You need to have a parameterized constructor, correct? But line number 69 resembles, resembles line number 71. Resembles, slightly resembles. Agree?
Yes.
Similar looking. So my question to you is, which would you use? Would you, if you have an option of using both, You have an option of using both. You can use line 69 also, and if you can use line 71 also. Assuming you can use both, which would you use and why?
71 because it will make a code more readable.
No, that's not the answer. 71, I agree, but your reason is not okay. In fact, 69 is more readable, na? If you're asking your readability, which is more readable? 1 second, which is more readable? Which do you all think is more readable? 69 is more readable, no? So don't tell me readability. That is not the correct reason. Yes, somebody else.
Because it is giving name parameter. So it's better.
It is not a name parameter. Madam, it is not a name parameter.
I mean, sir, yeah, we'll have a specific place for where this value is going. We can assign
Here also you know where it's going. Here also you know where it's going. So this is not a name parameter. Name parameter, what is the syntax? P1 colon something.
Colon, yes, sir.
That is not the same syntax. This is an object initializer. It's different from a name parameter.
Hello, sir.
So, yes.
Whenever we call the another reference for a particular class, at that time we have to default value P1, P2, and P3. In that second case, in the line number 71, we have the different value. I mean, not you have the default value for another reference.
Okay, so what are you saying? Which one would you prefer and why?
71 is prefer because we have to not have the fixed value. We can change the value for another reference. Suppose we have to use the 69 na. Whenever we use the another reference for class 1, in that case we have to already define value that 10, 20, 30.
Okay, I understood what you're saying, but what you said was absolute nonsense. Okay, I understood the point you're trying to make, but you have expressed yourself very, very badly.
Sir. Sir, in line 71, we need a constructor to set those values, whereas in line 69, we are directly setting the values as soon as we creating.
So my question to you is, assuming you have both options available to you, which would you prefer to use and why? That is my question. You're explaining to me what is happening. I want you to tell me which would you prefer and why.
69 because
69.
the coding part is reduced drastically. You don't need to create a constructor and all.
No. Okay. The first thing is you have to remember that you are not the guy who is creating the class. You're the guy who's creating the object here. Are you talking about creating the class here? Are we talking about creating the class? Somebody has created the class. Why are you always assuming that you are the same person who's creating the class? That is where your mistake is. You means not you, but everybody. Your mistake is, all of your problem is, you all keep thinking I'm going to do everything. I'm telling you that there are two people doing it. One is the developer and one is the user. Who's the developer? Who's the developer? Who's the developer?
Who is creating class.
Correct. And who's the user now? One who's creating the object. So I'm asking you to think that the user and the developer need not be the same person. So when you're writing code like this, you're right now only thinking about the user. You should not be thinking about the developer. So if you're telling me I have to write less code in the constructor, that is not your job. Who are you right now? You are the user. As a user, what would you prefer? Would you prefer line number 69 or would you prefer 71 and why? Don't tell me about the developer. As a user, which would you prefer? If you have both options, 69 and 71, which would you prefer and why? Is my question to you again and again.
So 71, sir.
Why?
So because we don't know if there is P1, P2 or P3.
I know, no? I know in 71. I know what is P1, P2, P3. Yes or no? Okay, it's not there here because I don't have that constructor, but here we saw that, right? When you open this, it's showing you P1, P2, P3. So yes, I'm still not hearing the right reasons. Okay, what if I told you 71 is preferred? That is the correct answer. Now you tell me the why. Yes.
Short code, less code.
Why? Why? What do you mean by less code? Writing less code or executing less code?
Writing.
No, that is not the reason. Okay, let me explain to you what is happening. Supposing I did line number 71. What is it calling now? What is it calling? It's calling the parameterized constructor in which the values are being set. Now, how many times is the values being set? How many times is the values being set? Just once.
Once.
3 values being set, but only once being set. No? Here, what are you doing? First part, what is it calling? First part, what is it calling? The no parameter constructor. So what will happen now? Values will be set there also. Yes or no?
Yes, sir.
Values will be set there also. Agree or no?
Agreed, sir.
Yes, sir.
After which, what is it again going and doing?
Set get methods are getting called again and
Not the get, the set methods are
set
getting called
methods.
again.
Yes.
So how many times are you setting the values? You're setting it twice. Once with the default values and once with the values that you actually want to set. So this code is running twice. P1 is being assigned twice, not once. And in this code, P1 is being assigned only once. So which is better? Assigning it twice or assigning it once?
Once.
Assigning it once.
Correct. So that is the reason why if you have an option of doing both, then 71 is always better. Always call the constructor if possible. If possible, if there is a constructor, use the constructor. When would you use 69? When would you use 69?
That we don't have constructor.
Only if you don't have constructor. Now, when you don't have constructor, you have to write code in this long way. So 69 is just a shortcut to writing code. Shortcut to writing this long code. But it is not as good as calling the code in the constructor directly. Are we clear on this?
Yes, sir.
All right. So always, if possible, use use constructors. And object initializers should be used only if the constructor is not available to shorten your code. Your code is still running as long, but to write shorter code, that's where you do object initializers. Okay. All right. Questions of any? All right. Now I got about 10 minutes left. I can't start off a new topic out here in 10 minutes because I will not finish the topic. And I also want you all to, whatever you have done right now, I want to give you a small assignment based on that. Okay. So this is what I'm going to do. This is the assignment that you have to work with in the lab right now. Before my next session, starts, try and see whether you can finish this. I'll be uploading this, but I just want to discuss this with you. So just take a minute to read through this and then I'll discuss this. All right, so let me take you through what I want. Create a class employee which has the following specifications. Firstly, all of these 4 are properties. What are the validations that we're giving here? This is the type of the property, string name. What are the validations given here?
No blank
No
spaces.
blank
Name
spaces.
should be allowed.
Blank
Yeah,
name.
so name should not be blank. Okay. Secondly, employee number must be greater than 0.
0.
Basic salary must be between some range. So you decide the range. Let's say between 10,000 and 1 lakh. Let's say I'm just giving a random number. So you decide what range you want it to be. And short department number also must be greater than 0. So I've just given you 4 different data types that you can actually use out here. Are we clear on the properties part of it?
Yes, sir.
Yes, sir.
Okay. Okay, now coming to the methods, there's one method here called decimal get net salary, which returns the calculated net salary. Use any formula to get the net salary based on the basic salary. So whatever the basic plus additions minus deductions will give you the net salary. Okay, is that easy to understand?
Yes, sir.
Any questions on that? All right. The third thing is, of course, create constructors to accept initial values to the employee object. So you have got 4 properties. You should be able to accept the value in all of these 5 different ways. Okay. So what are the 5 different ways? Either with no parameters and right up to what? Up to 4 parameters. 5 different ways of accepting it. Now, when you're trying this out, you're not going to first try out this code directly. You're going to first finish trying out all the examples that we've done in the class. You're going to get your concepts cleared first, and then you're going to start the assignment. So I'm okay if you don't start the assignment also. If you don't finish the assignment also, I'm okay with that. But you have to first try out all the things that you've done in class. Only after you've done all of that, after you're confident about that, then you start off doing this. All right. Any queries that you want to ask me before I end the session?
Sir, you will be sharing this?
Yeah, I'm uploading it. Give me 2 minutes to upload. So I'll
Okay,
be
sir.
uploading the code that I have given you, done with you yesterday and today. Yesterday's example, I added a couple of more things in the day 1 example, right? We added that static local functions today. So that part also I'm re-uploading, and I'll also be uploading this employee assignment. Okay. All right. So I had some problems logging into Zoom. So I'm actually logged in via my browser, and hopefully in the next session I should be able to log in correctly. But otherwise, I'm ending the session for now, unless there are any other questions. No questions? All right, then enjoy your lunch and see you post lunch. Bye for now. Happy coding.
Thank you.